Hi everyone, it's coming up to the end of November 2019. Christmas is just around the corner and I want to put back together my RetroPie gaming system. Yeah, so around 2 years ago now I created a 3D printed casing solution for the Raspberry Pi called the iDent CE, or C for short. There were three variants. You've probably already seen one or two of them. The original C unit, the twin stack, and then I created a video gaming system called the C Drive, a bit of a play on the whole Windows DOS pun. Now, the first two were relatively successful, but I never released the third, the gaming console system. A couple of reasons for that. One, I basically lost my nerve. Two, RetroPie, which it's based on, decided that it was no longer legal to sell or redistribute their Raspberry Pi distribution. And three, things like the Coleco Chameleon happened, which basically put a stop to anybody trying to put a gaming system on the market, especially one that was built around the Raspberry Pi. So I just decided, for me personally, it probably wasn't worth the hassle and the stress of trying to put a product on the market. However, I did very much enjoy the C console that I had myself, and as an emulator ROM box, it has actually been good fun. Well, we're coming up to Christmas now, and I'd very much like to have a bit of time off through December, January, and play a few retro games that I can emulate. Hence why I want to put my RetroPie CE back together. Before we start, a quick reminder about the PCB Way third PCB Design Contest. The competition is open and running now, with a deadline for entry on the 25th of April 2020. If you have a fantastic custom PCB design, why not enter? Top prizes from $1,000. Already entries are pouring in from all over the world, so why not join them? For full details, see www.pcbway.com/project/events/third design contest.htm. The best of luck. So let's start by bringing in the C drive unit as is at the moment. So it might look pretty complete, but there's no, as I said, I gutted everything inside. So it slides out like that, and then this is a two-part 3D print, and this is technically two parts, although the lamp holder here for the LED power light is a third component. It's still got the, show you that, it's still got the LED inside, and we've still got the connectors, so that's good. Now, originally this had a Raspberry Pi Model 3, one of the original Model 3s, and as I said in the intro, I ended up needing the board for another project, and the game console seemed to be the weakest link, so I gutted this to use the board. But as I said, I now want my game console back, so I thought, while we're here, we'll give it a bit of an upgrade, and I got hold of these, which are Raspberry Pi 3 Model B Pluses, and these are a slight upgrade on the original Model 3. With the Raspberry Pi 4 coming out, these have been heavily reduced, and I actually bought quite a few of these quite cheap, as vendors are trying to get rid of their stocks. Now, the Pi 4 won't fit in this unit, and many of you who are regulars to the channel already know my feelings about the Pi 4, so I'm quite happy with the Pi 3 B Plus. Get that out. There we go. You can tell it's a 3B Plus because it has the heatsink on the main processor. So this is the board we're going to use. It's plenty faster than what I need. And also just find my SD card, which I did label up. This was the original SD card that was used, and I'll just show you briefly how we actually go about flashing RetroPie to an SD card. If we head over to www.retropie.org.uk on a Mac or PC, and on the homepage click Downloads. We're then presented with two options for RetroPie, that for the Pi 0 and 1, and that for the Pi 2 or later. As we're using a later Pi 3 board, we'll click to download the latter. RetroPie's info pages show all the systems it can emulate. However, it should be noted that not all emulations are available on the Pi builds. With the RetroPie image downloaded, unzip it and then using Etcher, which is a free download, select the IMG image file, insert a blank micro SD card into your PC or Mac and click Flash. Once done, we can insert the new card into the underside of the Raspberry Pi. Now, the simplest thing I could do would be just to simply put the Pi, put the Pi back into the unit, which would mount like that, but inside. And then I could just reassemble it and we could get going very quickly. But as we're here, I want to make a few modifications to the original C design. So first thing I want to do is actually want to add a power switch. Now, the C unit itself was designed to have a number of additional add-ons. That's why it's got that extra space inside. So you could actually fit a Pi Zero in here, and you could even fit additional Ethernet USB connectivity as well. It has this panel here, which is designed to be popped out if you needed it, and originally it's for a USB socket to go in the front. So what I'm thinking is actually adding a power switch into this space here. I have these little on-off toggle switches. I really like these. I keep buying them off eBay. They're quite cheap and I use them in all sorts of things, especially products like this. So might install one of these and that'll go basically into that hole there. Now, if you do that, you then need a way of intercepting with the Raspberry Pi's power, because if you plug straight into Raspberry Pi and you're off the mains, then the Pi board just boots up basically and turns off when you pull the plug out. So we need a way of intercepting between here and switch. And the way to do that is to not use this power inlet, and instead you can buy these, which are little PCBs which have the micro USB, or is it mini USB? I forget if it's micro or mini, but I think it's micro USB type soldered on. And you can just snap these off. And again, there we go. So we have a single unit, and you've got the pins here for voltage. So you've got ground and voltage, data in the middle, but we don't really use data. So if we set up a circuit that we plug into here, then we can go to the switch, and then we can go back and power off the GPIO pins on the Raspberry Pi itself, meaning we don't have to use this port at all. Now, luckily with the C design, there's this panel and space here. You see the panel on the back. So we should be able to mount this inside here. And to mount this, I actually 3D printed a little custom mounting plate. So 2 screws, and we can fix that onto there. And then we can glue this piece of 3D print plastic, hopefully inside here. That's the plan anyway. Okay, so first thing we'll try and do is need to take this apart, and from memory there's screws, cross-edge screws just inside here, here, and one over here. There we go. Take the lid away, and that gives us the complete 3D printed, one-piece 3D print base plate. So we want to find the panel pieces, and we just take a pair of pliers, and we can pop the panels off. There we go. And if we wanted to, just get a knife and we can just clean up any excess plastic. Okay, let's see how well this switch is going to actually fit. It's not a bad fit, because the hole is actually designed for a USB socket, not a power switch. So the next question is, how well is that going to work if we put the lid back on? It's not too bad. course, if we want to, we can always take a little bit of plastic off. Yeah, a little bit more, but it's not actually bad, that at all. So we'll go with that. So that's fantastic. Let's focus our attention to the rear of the unit. So we've got this, which we want to use. And I think we need to start building up the circuit. So what I need is a way of plugging into, let's move out of the way there, plugging into the Raspberry Pi. And for this, I'm going to use GPIO jumpers, which are male one end and female here the other end. So you can actually plug these into the pins, and then we can either solder or plug the other end into our connection. So I'm just going to have a pair of snippers here, and we'll just cut off. There we go. Keep these wires apart a little bit, and we'll just peel the ends. There we go. Okay, so the way this will work is we'll use the dark orange as our ground, and we're going to wire the dark orange into the hole here, marked ground on the USB socket. The yellow we will go to one side of the power switch, and then we'll take another cable from the other side of the power switch to the plus side of this component. So let's get the soldering iron fired up. Got some fine core solder, and of course a bit of flux, which is a must for doing this sort of project. Okay, so soldering iron has just heated up, so we've just got our flux out. I'll just tin the ends of these cables. So we're dipping a bit of flux, got a bit of solder core already. Take a little bit of solder, and just tin the ends of our cables. Next we will put the orange cable through the ground hole, flip the thing over. Okay, that's now on there secure, which is great. So we're now going to attach the other end. And again, we'll just peel these back a little bit, so we've got a bit of flex to work with. Apply this to our switch. Again, being careful, especially not to get your fingers in the way. We'll just tin like that. Now what we have to do is just create a piece of bridging cable to go from here back to here. This is going to be our voltage wire, so really it probably shouldn't have been black, but it'll do for this. So we'll feed that wire, if we can, through there. And then finally, like before, we just need to bridge these two together. Good helping of flux. Okay, and that's on there securely as well. Okay, so now what we can do is we'll take the 3D printed base for this unit, and you can see how it mounts kind of like that onto the unit. And I have here some suitable pin screws, so we'll take two of those. This is why we want to wire the component before we actually fit it to the base. Take a screwdriver, and that is the 3D printed base now fitted. So now we bring back our base, turn it around, and we should be able to mount this sort of like that. But when I designed this, I actually put a hole here, so there isn't an awful lot for that to actually sit on without falling. You can see there, falling into the hole. So what I think we need to do is just put a panel of plastic, if we can, just into this gap, so we've got something a bit more secure to glue onto. Now to do that, I've got these which came in an envelope, and it's sheets of plastic styrene, or known as plasticard, and these are what modelers use for building things out of. So just literally a sheet plastic that you can cut and glue. And what we'll do is we'll cut a piece of this just to fill the floor area in the chassis, and then we can mount the components into that. Keeping the steel ruler, keep it straight, craft knife. There we go. And back to the chassis, and you can see that now fits nicely in there. So I've got here some super glue. Super glue really is the only stuff that will actually fit or fix PLA plastic. This tube is a little bit used, but should be alright. So we'll just put a little bit too much, but never mind. We'll just put the glue around like that. Then we can drop the plastic piece in. Trying not to get any of the glue on us if we can. Okay, so that's now set, or nearly set. So we can now look at placing our power socket kind of about there, I'm guessing. So again, we'll just put another little bit of glue just on the underside. That's all you need. Just fix that on top of the card. Now if we turn our attention quite literally round to the power switch, and we're going to need to glue this in carefully because we don't want to glue the switch up, so this has to be done very carefully. So a little bit of glue just on that ridge. We're only going to glue it one side. Make sure it's glued straight, it doesn't lean back. Okay, making sure we keep the wiring inside the case. Let's just test fit top panel again. And yep, that's fitting absolutely fine. So now we can actually fit our new Raspberry Pi board. Remember, we fitted it with the RetroPie on microSD already. So we've got these screw holes here, 4 of them, and we line that up with our Raspberry Pi, and again using these micro pin screws we'll now fix the Raspberry Pi into the chassis plate. Okay, that's the last of the 4 screws in, so the Pi board is now secure. The switch and the new power socket are in. We've got the cabling bus. So we now need to attach these two to a positive and negative feed on the Raspberry Pi's GPIO, because that's how we're going to power this board. Now this diagram here shows you a Raspberry Pi's GPIO, and if we turn it the correct way in relation to the pins here, we want to find a 5-volt positive, which is this one here, and that will be the yellow cable, and then we need to find a ground. I want to keep these 2 spare, and I'll explain why in a moment. So here's a ground over here, which is pin 9. So that'll be, where are we? That one there, that'll be ground. So we just try and bend these cables back out of the way a minute. And that should now be wired in and technically should work. Just put that to the side a moment and just concentrate on the outer case, which does separate into 2. And you'll notice that there is this recess in the top lid, and that, believe it or not, is to add a cooling fan, which is useful especially if you're running the emulators for things like the Nintendo 64 or the PlayStation 1, as it does make the Pi run very hot. So those are now in there, and we can just put nuts on the other end. So the cabling for the fan is 5 volts. So we have positive and negative again. And let's just check. So the colour, the purple, is positive. So let's go back to our GPIO diagram and we'll fit 5 volts positive there. And right next to it is the ground. So I want to keep this empty, and we'll put those on like that. And that's our cooling fan now into the system. So I'm just going to now fit my case top back on. And finally, we take the 2 leads that are left for the 3.3 volts that are required for the power LED. And we look at the diagram, we can see that pin 1 is positive. So we'll connect to pin 1 and then we'll find the nearest ground that's not occupied. And there's a pin 14 that'll do, which is there. Make sure we get all the cabling inside, and now if we're very careful, you can slide the unit shut, and there's just one final screw in there, and that just secures the unit top part to the main chassis. Okay, what I think I might now do is just look at finishing up this big gap area here, because we've now got 2 power sockets, which looks a bit confusing. So this one here I'm going to plate over with a piece of plastic, and then we'll see if we can cut a piece of plastic to fit over there. So about 20 minutes later, we've now got the plastic parts done, so that will fit on there, and that will fit in there. So that's this one first. Now, because these 2 pieces have to come apart again, we're only going to glue along the bottom here carefully. We don't want to glue anything together that we didn't mean to. So a bit of glue like that. Make sure we get this lined up the best we can. I'll fix that plate on like that. Dab of glue there, dab of glue there, that's all you need. And fit the plastic plate on. And there we go. And that will just help finish that up quite nicely. And here we have the finished unit, which I'm really pleased with how well that's actually come out. So I guess the next thing we need to do is test it. So we'll take a standard Raspberry Pi 5 volt power supply. Now bearing in mind this is the oldest type of Pi, so it takes the micro USB connector. So we'll plug that now into our new socket. HDMI, knowing this is going to output at least a 720p signal. So we'll now plug HDMI in. And now we're going to need a controller. I'll try one of these cheap SNES clone USB controllers. These have always worked quite well for me, and you may have seen them, I've used these in the first few projects. So they're cabled in, of course, and the USB lead goes in on the side of the unit. So the moment of truth. Let's power up and see if all has worked. The power LED has come on, and we can hear the fan spinning. And now we've got video with the RetroPie splash screen and Linux kernel. Well, I think we'll leave that there for the time being. In the meantime, if you're interested in the CE casing system, you can find RISC CE units available for sale at my good friends at riscosbits.co.uk. And do join us again for part 2, which will be forming part of this year's Wi-Fi Sheep Christmas content. That's right, Christmas 2019 here on Wi-Fi Sheep. We'll be putting the RetroPie CE unit up against real retro computing hardware to see which will come out on top. Later we'll be revisiting the full-size C64 clone system due for release in December 2019. We'll see if it's any good, especially with that fully working keyboard built in. And finally, in the new year, we'll hit the rails as we explore the use of Raspberry Pi and digital command control for operating and driving model trains. The age of the humble train set is long behind us. So, lots to look forward to right here on the channel, and I've got a lot of work to be doing with editing, etc. To make sure you don't miss any of that content, don't forget to like and subscribe to us here on Wi-Fi Sheep. And as ever, I'll see you real soon right here on the channel. Until next time, bye for now.